Today we'll be learning about parent functions. Our objectives are that we will be able to recognize graphs of parent functions given an equation or given a graph, and students will describe the domain, range, and end behavior of each parent function. So take a minute, see if you can match all of these equations with their correct name. Pause your video if you need to. For the cube root function, we're looking for a function with a root, so either a or e, but because it's cube root, it needs to have the little 3 in the root, like we do here on letter E. Absolute value has the 2 straight lines around the x, so letter D. A square root function has the root, but it doesn't have any number there, so A. Quadratic function has a squared in it, so it's C. And cubic has the third exponent, so it's letter B. So let's see what these functions look like. So we're going to choose appropriate input values, or x's, to generate the table of values, sketch each function, and state the domain, range, and end behavior. So like we said at the top, the 2 straight lines around the x mean this is the absolute value function. We can take the absolute value of any number, so we're going to use -2, -1, 0, 1, and 2. Absolute value means the distance from 0. So how far is -2 from 0? It's 2 spaces. How far is -1 from 0? It's 1 space. 0 is 0 spaces from 0. 1 is 1 space from 0. 2 is 2 spaces from 0. So I'm going to plot these x, y values on my table. So on my graph. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And you can start to see here that it makes a V shape. And it's going to continue on both sides forever, so we're going to put arrows on both ends. Since it has arrows on both sides, and we can take the absolute value of any number, that tells us our domain is -infinity to infinity. Our range, the bottom of our graph, is at 0, and the ends both point up, so it goes from 0 to infinity. And our end behavior, since both arrows are pointing up, both end behaviors are going towards positive infinity. Our next function has the little squared, which means it's the quadratic function. Again, we can square any number, so we're going to use -2, -1, 0, 1, and 2 as our x values. And I'm just choosing these numbers because they're easy to work with. Technically, you could put any number in there you wanted. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So I'm going to plot them. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now this may look like it's making a similar shape as the absolute value function, but this is more of a U shape than a V shape, so it's going to curve a little bit at the bottom. Again, since we have arrows on both sides and we can square any number, our domain will be -infinity to infinity. Our range, the bottom of our function, is at 0, and it goes on till infinity. And both of our arrows are pointing up, so our end behavior goes towards positive infinity for both ends. Next, we have the square root function. Now, we can't square root every number. We can only square root positives, and for the purposes of what we're doing, we want to square root perfect squares so that we get whole number answers. So I'm going to use 0, 1, 4, and 9 as my x values. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So let's plot those. 0, 0, 1, 1, 4, 2, and 9, 3. So this one's going to curve. It's going to kind of look like an eyebrow, and we're going to put an arrow on the right-hand side because we can keep going and take square root of bigger numbers. But because we can't square root negatives, we're going to have an end point here, and it won't continue. Since it stops at 0, that means our domain is from 0 to infinity. Our range, the bottom, is at 0, and then it goes up forever. And our end behavior looks a little different this time. Because there's only one arrow, there's only one end behavior, and that one arrow is going towards positive infinity. Fourth, we have our cubic function, and we can cube any number. So I'm going to use -2, -1, 0, 1, and 2 again. -2 to the third power, which means -2 times -2 times -2, would be -8. -1 cubed would be -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. So -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. This kind of makes a sideways S shape. And arrows on both ends because it continues forever. Since we can cube any number, and we have an arrow on the left and an arrow on the right, the domain is -infinity to infinity. Our range, since we have one arrow pointing down and one arrow pointing up, the range is -infinity to infinity. End behavior is a little different this time. As x goes to the positive, so that's on the right-hand side, that arrow is pointing up, so positive infinity. As x goes negative, that's the left-hand side, so that's this arrow is pointing down to negative infinity. Our final function is the cube root function. Similar to how we use perfect squares for square root, we want to use perfect cubes for cube roots. And conveniently, we just calculated some perfect cubes on the last function. These right here, the y values from our cubic function, are all perfect cubes. So I'm going to use those as my x values. -8, -1, 0, 1, and 8. The cube root of these numbers are the x's that we started with in the cubic function. So -2, -1, 0, 1, and 2. So let's plot these. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. domain, since we have an arrow on the left and an arrow on the right, will be negative infinity to infinity. It might be hard to see, but as this arrow moves to the left, it's slowly moving down towards negative infinity. And this arrow is slowly moving up towards positive infinity. So our range is negative infinity to infinity. And our end behavior, as x goes positive, so the arrow on the right is slowly moving up towards positive infinity. And as x goes negative, meaning the arrow on the left, that arrow is slowly going down towards negative infinity. That's all for today. See you in class.